Assalamu alaikum dear students, I am your chemistry teacher Haris Jeelani, and today we are going to start our new chapter, that is acids, bases and salts. So I am going to write down here acids, bases and salts. I will start with the classification of compounds. In ancient times, earlier times, compounds were classified on the basis of source. Compounds, I repeat, compounds were classified on the basis of source. So compounds were classified on the basis of source. Fine? Source. If the source was directly from plants and animals, the compounds were called as organic compounds. I will repeat, if the substances were derived from plants and animals, the compounds or the substances were called as organic compounds. In a similar way, if the source was rocks and minerals, that is, the compounds were derived from rocks and minerals, the compounds were called as inorganic compounds. Fine? So, what I said is, in earlier times, ancient times, compounds were classified on the basis of source. On the basis of source, if they were derived from plants and animals, they were called as organic compounds. If they were derived from rocks and minerals, the compounds were called as inorganic compounds. So, what happened later? Later, with the advancements in the science, we started grouping the compounds. That is, we started classifying the substances. As soon as we started classifying the substances on the basis of certain characteristic properties, we started classifying the substances on the basis of certain characteristic properties. Like what properties? If the substance tasted sour, they were called as acids. So, the classification was based on the taste. Moreover, if the substance conducted electricity in its aqueous solution, it was also called as acid. So, the substances were classified on the basis of certain properties. What properties were they? If they tasted sour, they were called as acids. If they conducted electricity in its aqueous solution, they were also called as acids. Fine? Okay. In a similar fashion, the substances that tasted bitter were called as bases, or the substances that were poor conductors of electricity in their aqueous solution, they were also called as bases. Fine. So, the earlier classification was basically on the certain characteristic properties of the substances. I repeat from the very beginning. Compounds were classified on the basis of source. If the origin was, that is, the compounds were derived from plants and animals, they were called as organic compounds. If the same compounds or the other compounds were derived from rocks and minerals, they were called as inorganic compounds. So, what happened later? We started classifying the substances on the basis of certain characteristic properties. So, what were the properties? If the substances tasted sour, they were called as acids. Moreover, if they conducted electricity in its aqueous solution, they were called as acids. Moreover, I would say, if they reacted with a metal, if a certain substance reacted with a metal and released hydrogen gas, they were also considered as acids. Fine. So, what we have to deal in this chapter is the three components, that is basically the acids, the bases and the salts. Now, looking at our syllabus of class 10th, we will study in brief about acids, in bases and salts, and what are the different theories and concepts regarding acids, bases and salts. Fine. Okay. different scientists put forward different theories regarding the acids, bases and salts, or there were different concepts regarding acids. So basically we have three concepts or three theories regarding acids and bases, three theories. First one called as Arrhenius theory, or we call it as Arrhenius concept. Fine, it was put forward by Svante Arrhenius in 1884. Fine. The second concept is called as Bronsted-Lowry concept, and third concept is called as Lewis concept of acids and bases. So what we actually have three theories, or we can say three concepts regarding acids and bases. The first one being Arrhenius theory or Arrhenius concept put forward by Svante Arrhenius in 1884, and then the Bronsted-Lowry concept, and the third one, that is Lewis concept. So we will be starting with the first one, that is Arrhenius concept of acids and bases. Let me begin with Arrhenius concept of acids and bases. So it was Svante Arrhenius, who was a Swedish chemist from Sweden. He was a Swedish chemist who put forward the theory of acids and bases in 1884. I repeat, Arrhenius theory or Arrhenius concept, this is the first concept we are dealing with. Arrhenius concept or Arrhenius theory, it was put forward by Svante Arrhenius in 1884. He was a Swedish chemist. What he said? He said, I would classify a substance on the basis of what kind of ions will be formed when a substance is added to water. I repeat, this was only the base, this is not a concept. This is the base that Arrhenius put forward while classifying a substance. How do I classify? I would give a certain base of that. In a similar way, Arrhenius put forward a certain base. The base was, he started classifying a substance on the base of ions that particular substance would perform. What kind of ions would that substance form when that substance is added to water? So I am repeating this again. Arrhenius, what Arrhenius did? Arrhenius said he will classify a substance on the basis that what kind of ions that particular substance will form when that substance is added to water. Fine. So what did he said? Arrhenius, he said, this is the definition of acid as provided by Arrhenius. An acid is a substance or is a compound that releases, or we can say furnishes, H positive ions as the only positive ions in its aqueous solution. So, according to Arrhenius, what an acid is? Acid is a compound that releases or furnishes H positive ions as the only positive ions in its aqueous solution. That means if a substance is acid, when it will be dissolved in water or it will be dissolved in aqueous solution, it will release me H positive ions. Fine. Example, HCl. When HCl is dissolved in water, that is in aqueous solution, it dissociates into H positive and Cl negative ion. So it furnished H positive ion, hydrogen ion. Fine. So acid is a compound that furnishes what? H positive ions when that particular substance or compound is dissolved in aqueous solution. What I did? I took HCl. I dissolved it in water. What I got is H positive and Cl negative. H positive. I got the hydrogen ion. So HCl basically furnished H positive ion. So HCl is my acid. It is called as hydrochloric acid. Fine. So this reaction is called as dissociation of HCl. Dissociation. I ionized it, dissociated it into ions H positive and Cl negative. If I got H positive ion from a particular substance, then that substance is acid according to Arrhenius. I am going to repeat it again for you that what an acid is. What does acid mean according to Arrhenius? An acid is a compound that releases or furnishes H positive ions as the only positive ions. By this statement, as the only positive ions. By this statement, as the only positive ions. What do I mean? If I have a compound, example, I have a compound NaOH. NaOH. If I am dissociating NaOH into water, what I am getting is Na positive and OH negative. I got the positive ion, but the positive ion over here is Na positive. It is not H positive according to Arrhenius. Na positive is a positive ion, but H positive. What does Arrhenius said? Arrhenius said it should furnish H positive ion. NaOH, it has the positive ion, but it is not H positive. That's why I wrote as the only positive ion. The positive ion should only be H. It cannot be other than H. It cannot be Mg positive. It cannot be Ca2 positive. It should only be H positive. Fine? Oh, let us go with the second statement, that we can define this particular thing over a second statement, that is any species, according to Arrhenius, any species that increases the concentration of H positive ions, that is hydrogen ions, when added to water is called an acid. That is any species that increases the concentration, that is the number of H positive ions, hydrogen ions, when added to water is called an acid. This is the second definition put forward by Arrhenius, that is any species that increases the concentration, that is the number of H positive ions are increasing. Number of H positive ions are increasing when that substance is added to water. What do we mean by this statement? Let us clear this by the help of an example. Look at here. H2O is itself made up of H positive and OH negative. Clear? H2O, it is made up of H positive and OH negative. So it contains basically one H positive ion and one OH negative ion. Fine? One H positive and one OH negative. What I am doing, I am adding HCl to it. I know HCl dissociates into H positive and OH negative. Let us count the number of H positive ions. H2O itself contains one H positive ion. On dissolving HCl into H2O, there is another H positive ion that HCl releases. The total number of H positive becomes 2. Total number of H positive. HCl, H positive, it gave out H positive. H2O itself made up of H positive. So there are 2 H positives in the water now. Basically it was 1, now it becomes 2. So the concentration, the number of H positive ions got increased when HCl was added to water. So the HCl species here is an acid. That is any species that increases the concentration of H positive ions when added to water is called an acid. H2O, HCl, H2O itself made up of H positive and then OH negative. HCl made up of H positive and OH negative when it's dissolved in water. H2O contains one H positive. When HCl was added to water, another H positive came. So the number of H positive ions got increased, their concentration, their number got increased, it becomes 2. So that species that increases the concentration becomes an acid. So what was an acid according to Arrhenius? According to Arrhenius, an acid was a substance that released or furnished H positive ions as the only positive ions, And then second one, any species that increases the concentration of H positive ion, that is hydrogen ions, when that were added to the water. Fine. This was all about the acid of Arrhenius. Now, what we see in actual practice. What do we see in actual practice? In actual practice, H positive ions, also called as protons, since H positive is a proton, how? Let me clear it over here. H positive, it is hydrogen, its atomic number is 1, that means number of protons is equal to 1. For an atom, we know number of protons is equal to number of electrons. We know this thing. Again I am repeating, hydrogen, atomic number 1, number of protons 1. For an atom, number of protons is equal to number of electrons. So hydrogen atom basically has 1 proton and 1 electron. Okay, fine. When hydrogen loses, it forms H positive and it loses this electron. Fine. So in H positive, 1 electron is lost. What remains there? There is only proton. So we say H positive as protons. So in actual practice, what we see? Protons. In actual practice, what we see is protons, H positive ions, are unstable in water. Fine. What do they do? H positive ions, what do they do? H positive ions react with the surrounding water molecules. H positive ions react with the surrounding water molecules. I am talking about when an acid is dissolved in water, we say H positive ions are released. What actually happens there? H positive ions are very unstable. So what happens there? These H positive ions react with the water molecules, surrounding water molecules in the water, and form H3O positive ions, also called as hydronium ion, and we may call it as oxonium ion. As the simplest oxonium ion is the hydronium ion. I am repeating again. In actual practice, what Arrhenius said, he said acid is a substance that releases H positive ions. But in actual practice, we see, are there the H positive ions floating over the surface of water? No, they are not. They are very unstable. H positive ions are very unstable. They react with the surrounding H2O molecules in the water and form H3O positive ions. That is, we call it as hydronium ion or oxonium ion, and we have studied that hydronium ions contain a special type of bond that is called as dative bond or coordinate covalent bond. It contains a special type of covalent bond that is called as coordinate covalent bond or dative bond. Fine. So what we saw is, in actual practice, H positive ions that acid releases goes into the water, reacts with the water molecules over there, combines with them and forms H3O positive ions. So what is there when an acid is dissolved in the water? What is there? There is no H positive ions. There are no H positive ions floating over the surface of water. What are there? There are only H3O positive ions. That is the hydronium ion. We may also call it as oxonium ion. What is an oxonium ion? I will repeat, the hydronium ion, oxonium ion. When any oxygen contains 3 bonds, when an oxygen is bonded with 3 different atoms, we call it as oxonium ion. Fine, very clear. So this was about the acid. Fine. There's a little concept I want to discuss with you, that is protonation of water. What do we mean by this statement, that is protonation of water? Clear? Protonation of water simply means that when a proton, H positive ions, I discussed this here, H positive ion is a proton. When proton is added to the water, it results in the formation of H3O positive hydronium ion. This is called as protonation of water. When a proton is added to the water and the resultant of their combining is hydronium ion, we call it as protonation of water. Clear? Fine. This was about Arrhenius acids I am going to recapitulate only for you. What Arrhenius said? Arrhenius said acid is a substance that releases or furnishes H positive ions as the only positive ions in its aqueous solution. Means if we have to classify a substance, whether it's acid or base, we have to dissolve that in water. If it releases H positive ions, it may be an acid. And the second statement was, if any species increases the concentration of H positive ions in the water, it may also be called as an acid. In the next lecture, inshallah rahman, we will be discussing about the base. What do we mean by Arrhenius base? And further we will discuss about the classification of acids on different bases in different compounds. Thank you very much. Assalamu alaikum wa rahmatullah.